So solving this next equation, here's how we're going to get after this one. We want to solve for x. And before you make any rash decisions, you really want to just observe what's going on, everybody. Here's what we have. We have our equal sign right here, okay? That's where my equal sign is. So you tell me in the chat box, everybody help me out. The 3x and the 7x, are they on the same side or opposite sides? You tell me. Yeah, they're on the same side. So when they're on the same side, we don't need to move them to the same side because they're already together. What we're actually thinking of doing here is combining like terms. That's what we want. So checking out 3x and 7x, 1 plus 2 plus 3 is the same as 3 plus 2 plus 1. It's all good. So 3x plus 7x, what does that give us, everybody? Yeah, 10 of those x's together. So we have 10x plus that 13 that we didn't do anything with equals 83. Up next, what we're going to do is we're going to get that x by itself now. We finally have the variable as just one term with the variable, and so everything else can start going away now. I'll start by getting rid of the plus 13 by subtracting 13 on both sides. Once we do that, cancels out on the left, giving us 10x equals 70. And then from here, everybody, dividing both sides by 10 gives us the nice final little step here. Cancels out on the left, giving us x equals 7. And so the correct answer here is answer choice D, 7. In this next question, we're going to begin, as always, read that question sentence. And it says right over here, what is the ratio of veterans to juniors? So let's make sure we read that again, everybody. What are the two things that we're trying to compare? Tell me again, what is the ratio of what to what? Yeah, the ratio of veterans to juniors. Okay, so let's go ahead and write that down here. That's the comparison that we want. Let me just go ahead and say here, veterans, and we are comparing to, let's just write juniors over here. And the reason that I'm writing it over there is because, if I were to put this together here, everybody veterans and juniors directly compared in the problem statements? Are veterans and juniors directly compared? No, they're not. I have juniors and seniors. There's juniors, not seniors, but there's juniors. And then I have seniors to veterans. There's veterans, not juniors. So we have an indirect connection. This is what's called a chained ratio. There is a chain. There's a middleman that we're going to take advantage of. So here's what I'm going to do. I'm going to write these chains, these ratios, over here on the side. So I'll go ahead and say juniors to seniors, 5 to 2. So I'm going to put a J for juniors, S for seniors, and that is going to be 5 to 2. Then I'm also going to look at the other comparison that is made in green. So I'll write this down over here. Ratios of seniors to veterans is 2 to 3. So I'll say over here, we have seniors to veterans, and we'll say 2 to 3. So everyone, if we're trying to compare juniors to veterans, specifically, if we're trying to compare those two things, is our middleman seniors, is our middleman the same? Is our middleman the same? Yeah, right? It is. Our middleman is the same. And because the middleman is the same, yeah, we are good. We can go ahead and make that comparison. We can make the jump and compare juniors and veterans. We can absolutely do that. But here's the one massive problem that, through all the confusion, people will make at the end. The biggest mistake that people will make at the end is forgetting that we have the order given to us. Veterans first, juniors second. If we go off of this over here, we have juniors written first, veterans listed second. So the answer is not 5 to 3. The answer is going to be 3 to 5. That is the proper comparison. Veterans to juniors. That's the final answer, and that's why we have answer choice A. Hopefully that was a good one for you, my party people, because again, it's all about the story, not the numbers. All right, up next, we are solving for x. And so what we see here are decimals, for sure. That's okay. We'll handle it. But we have 2.5x plus 0.5 equals 18. So with that said, what we're going to do is we're going to handle this like we know how, as if it were whole numbers or anything else. We know that it's operation-based, and we're just trying to work backwards. Just because we're dealing with decimals doesn't make a difference unless you seriously have been avoiding practicing with decimals, and we'll let this be your wake-up call. So here we go. We have 2.5x plus 0.5 equals 18. We know that we're multiplying over here, adding over here, and so we can get rid of the 0.5 first on the way to getting the x by itself. So we'll subtract 0.5 from both sides. And there we go, cancels on the left, leaving us with 2.5x. And if we look at 18 minus 0.5, then we're looking at 17.5. That's like saying subtract 50 cents, and there we go. So now that we're here, the last thing that we'll do is undo whatever's going on between the 2.5x and the x. So what operation is currently happening in the front here? Multiplication. So we are going to do the opposite of that, and we are going to divide to get the 2.5 out. So right over here, let's go ahead and do that. Divide 2.5 from both sides. And again, it will cancel out right here on the left, leaving us with x equals whatever 17.5 divided by 2.5 is. Now, let me give you some advice when it comes to dealing with decimals. The easiest way to divide by a decimal is to not divide by a decimal at all. The trick is to move the decimal on the denominator, which is right over here. We're going to move that decimal to the right as many times as we need to until we have a whole number. Everybody, tell me right now, how many times do I need to move that decimal place to make a whole number? Just once, right? Just once. Take a look here. From here to there, that's just once. Now, do you guys remember hearing at some point in school, whatever you do to the denominator, you do to the top? Whenever we're talking about multiplication or division, do you remember that? Yeah, and if you remember that, this is the exact situation that we're doing here, because we move the decimal to the right in the denominator, and so we'll do the same in the numerator. So all we're saying with this, everyone, all I'm saying with this is that 17.5 divided by 2.5, that's the exact same thing as 175 divided by 25. Once you move those decimal places over, the same amount, top and bottom, boom, there you go. So now that we have this, we can write that out, 175 over 25, and we can, show this as long division if we want to, which is pretty pointless here. But we're going to ask ourselves, how many times does 25 go into 175? 7 times. Let's prove it. 25 multiplied by 7. That'll be 5 times 7 is 35. And then 2 times 7 is 14. Carry the 3 is 17. And so, yeah, absolutely, we have our answer there. 25 times 7 is 175. You can put a decimal on it, and that would come out to 17.5. So the correct answer here, everybody, is answer choice C.